Hello class, so I thought it'd be a good idea if I started going over the homework and recording it as a video for you all to have as a resource, so you not only have the answer document, but you also have me going over the procedures for you. So today we are on Module 5, and Module 5 is on systems of equations, and a system of equations is basically any two or more equations that are related to each other. So let's get into it. Number one, solve the following systems of equations. So there are three main ways of solving for systems of equations, and that would be through the elimination method, that would be through substitution, and that would also be through graphing it, so doing it graphically and seeing where they intersect. Now, my favorite personally is substitution. It makes most sense to me mathematically, but sometimes if a question lends itself to elimination, I will do the elimination method, or if I have a graphing calculator, or if I'm on Desmos right there, I could also just graph it. But let's start with A. So looking at A, I see that this problem really lends itself well to the elimination method, because I see here I have two functions, and I see that they both have 3a. And I notice that if I just were to multiply either one of these functions by a negative, it would change the function such that I can eliminate one of the 3a's. So what I'm going to do here is this second equation, I'm going to multiply it by a negative, which is really going to change the equation. It's going to change each sign. So now what I'm going to have is I'm going to have 3a plus 3b equals 21. I didn't do anything to the top equation. And the bottom equation is just going to change the signs here. So 3a becomes negative 3a, negative 4b becomes positive 4b, and negative 14 becomes positive 14. Now what I can do is I can combine these like terms, or you can think of it as adding or subtracting them together, and I am going to eliminate the a, because we'll notice that 3a minus 3a zeroes out. It gives me 0 3a's. So what I'm left with is 3b plus 4b, which is 7b, equals 21 plus 14, which is going to be 35. At that point, I can just solve for b. So I can divide both sides by 7, and b is equal to 5. So now that I've solved for b, I can plug b back into either one of the equations and solve for a. I'm just going to use the first equation. So I'm going to plug in, let's see, 3a plus 3b, but b I know now is 5, equals 21, and then I just solve for a. So I'm going to multiply 3 times 5, that's 15. Subtract 15 from both sides. This give me 3a equals 6, and divide by 3. So a is equal to 2. And there I have my two answers. B is equal to 5, and a is equal to 2. So let's move on to B. And here I'm just going to use the substitution method. I see that this bottom function, all I need to do is move this 4n over in order for me to solve for m. So I'm going to do that. So when doing the substitution, I'm going to solve for a variable first, and I'm going to solve for this m. So I'm going to add 4n to both sides, which will give me m is equal to 12 plus 4n. Now, at this point, what I'm going to do is I'm going to take this equation and I'm going to plug it into the other function, or the other equation, and solve for n. So I'm going to take a look at the first equation. It's 2m, but I know m is now equal to 12 plus 4n, so I'm going to substitute that in. And solve for n. So here I'm going to want to distribute this 2, so that's going to give me 24 2 times 4n, that's going to be 8n, minus 2n equals 3. I can combine my like terms and subtract that 24 over. So if I subtract 24 from both sides and combine like terms, I'm going to have 6n is equal to negative, let's see, negative 21. And then I'm going to divide by 6. Sorry, I'm running out of room here. So n is equal to, let's see, negative 21 over 6. That will be negative 3.5. So negative 3.5. I'm just going to go to a decimal here. So now that I have that, I can plug in that in for n in any equation I see and solve for m. So I'll just plug it into the second equation. So let's see, we have m minus 4n, but 4 times negative 3.5 equals 12. Negative 4 times negative 3.5 is going to be positive 14. So m minus 14 equals 12. Add 14 to both. Or sorry, it's going to be positive 14. Negative times negative. And then subtract 14 from both sides. M is equal to negative 2. So here we have our two answers. N is negative 3.5 and M is negative 2. So moving on to C, again, well, this is an interesting case because take a look. They're both equal to D, which means that I can say that they're both equal to each other. If one thing is equal to something and something else is equal to that same something, then those two things, or well, all three of those things are equal to each other. So I can set this up as 2x minus 12 equals 4x, or negative 4x plus 18. And then now I can solve for x. So I want to move all my x's to one side, all my constants to another. So I'm going to add 4x to both sides. And I'm going to 4x to both sides. So I'm going to have 6x minus 12 equals 18. And then add the 12 to both sides. So let's see, 6x is equal to 30, and then divide by 6. So x, I know, is 5. Now what I can do is I can just plug in 5 in for x on either of the equations and find my d. I'll just use the first equation. So d is equal to 2 times x, but 2 times 5, minus 12. That's going to be 10 minus 12, which is d equals negative 2. So here we have our x value and our d value. All right, so moving on to the next one. Let's see, what would be a good method here? I am just going to, well, notice that y is already solved for itself on the first equation. So what we can do is we can substitute this in for y down here into the other equation and solve for x. So let's see, we're going to have negative 3x plus 2 times y, but I know y to be this 2x plus 8.1 equals 14.2. And now I just do some math. I'm going to distribute this 2 and solve for my x. Oh, that's going to be 4x. Sorry about that. So negative 3x plus 4x, let's see, plus 16.2 is equal to 14.2. Combine these x's, so x, and I'm going to move this 16.2 over. So x is equal to negative 2. And now I can plug in negative 2 in for x into any of the equations and solve for my y. I'm going to use the first equation here because it's already set up to be solved for y. Let's see, 2 times negative 2 plus 8.1 equals y. This is going to be negative 4 plus 8.1 equals y. So y is equal to 4.1. And we have our two values. We have x and we have our y. And then finally looking at E, let's see here, we'll just do another elimination just because we've only done one so far. So here I see that if I multiply my second equation by 2, then my x's will cancel out. So if I multiply my second one by 2, my first one stays the same. I'm not doing anything to that. And I multiply my second one by 2, that's going to be negative 4x plus 2y equals 26. And now you can see that my x's cancel. So negative 3y plus y is negative y. And negative 31 plus 26 is going to be negative 5. And we just divide out that negative, so y is equal to 5. Now, I'll just plug it into any of the equations and solve for x. Let's see, I'll just plug it into the first one. Let's see, so we have 4x minus 3y, 3 times 5, so y is 5 now, equals negative 31. So 4x minus 15 equals negative 31. Add 15 to both sides, and when we do that, we're going to get 4x is equal to, let's see, negative 16. Yep, 4x, negative 16, and then divide both sides by 4. So x is equal to negative 4. And there we have it. So that's how we do this algebraically. Let's take a look at some problems in context. So the admission fee at a town's fair is $2 for children and $5 for adults. If 2,457 people enter the fair and $7,410 is collected, how many children and how many adults attend? So part A, we need to write two equations that model the situation. We need to be sure to clearly define any variable used. In part B, we need to then solve that system to determine how many children and how many adults attended. So let's first start off by defining our variables. So x, well, I'm just going to use x and y. X is going to be the number of children, and y is going to be the number of adults, because that's what we're looking for. So we need to create two equations here that are essentially true statements. And this kind of takes some thinking about how to do it. But I'm going to make a statement that refers to how much total money was collected and the total number of people who entered. So starting with the money, I know that it's $2 per children. So 2x, that'd be the total number or total dollar value for children. $2 times how many children entered, plus the $5 per adult, it's going to be $5 per every adult that entered, is going to equal the total number collected, 7,410. My second equation is going to talk about how many people entered. So I know the number of children and the number of adults together equal the total number attended, 2,457. So this is the system of equations that I want to use, my two equations. Let's now solve for this system. And I'm just going to use substitution here. This bottom equation looks pretty easy for me to work with. So I'm going to solve for y here. So notice if I just subtract x from both sides, my equation becomes, well, I'll show you. Well, no. Let's see. X plus y equals 2,457. If I subtract x from both sides, I get y equals 2,457 minus x. So now I'm going to take that and plug it into the other equation, in for y. So I'm going to have 2x plus 5 times 2,457 minus x equals 7410. And then I'm going to solve for x. So I'm going to distribute this 5. So we have 2x plus, let's see, I'm going to get my calculator out. I don't want to chance giving false numbers here. Okay, 5 times 12,285 minus 5x is equal to 7410. And then combine our x's, so 2x minus 5x is negative 3x. And then I'm going to subtract that 1,200 or 12,285 over. So negative 3x is equal to, let's see, negative 4875, and then divide both sides by negative 3. So x is equal to 1625. So 1,625. So what that represents is the number of children. So I know that 1,625 children entered the fair. Now let's find the adults. So I'm going to plug it into the second one because this is an easier equation to work with. And so let's see. I now know that 1625 plus y is equal to 2457, the total number. And then just subtract it over, which should be pretty evident because the difference of these numbers will give us the total amount of adults. So let's see, that would be 832. Let me just check. Papers flying everywhere. Sorry about that. $832. So let's kind of think about this. We'll write the answer in our words. So we know that 1,625 children and 832 adults attended the fair. And that's that. So let's move on to the next problem, number 3 here. This is saying Chip and Dale both went to the store to buy snacks, chips and soda, for a party. Chip paid $18 before tax and bought 2 4-liters of soda and 3 bags of chips. Dale paid $20 before tax and bought 4 2-liters and 4 bags of chips. So note, assume that they each paid the same price per item. So what is the price of 1 2-liter bottle of soda, and what is the price of 1 bag of chips? So part A, we need to write 2 equations that model the situation, and we need to find our variables. And part B, to solve that system and determine the answer. So let's see, it doesn't give us variables to use, so I'm just going to use x and y again. So let's see, we'll say the x is the price of soda. And y will be the price of chips. Oh. Sorry, let's see, chips. Okay. So let's model the situation with 2 equations. One equation is going to be Chip's transaction, and the other one is going to be Dale's transaction. So Chip bought 4 2-liters of soda, so that'd be 4x, and 3 bags of chips, so 3y. And he spent a total of $18. Dale, let's see, bought 4 2-liters and a total of 4 bags of chips and spent a total of $20. So let's go ahead and solve this system. I'm going to use elimination here, because I can see if I multiplied one of the signs by, or one of the equations by a negative, that one of these 4x's will go away. They'll zero out. So I'm going to go ahead and multiply the first one by negative. So the first equation is going to become negative 4x minus 3y equals negative 18. And the second equation I'm not going to do anything to. So when I combine these like terms, these x's zero out. Negative 3y and a positive 4y is just going to be y. And negative 18 and 20, that's going to give us a 2. So y is 2. The price of chips is $2. Now I can plug it into any of the equations and solve for the price of the soda. I'm just going to use the first one. So 4x plus 3 times 2 equals 18. That's going to be 4x plus 6 equals 18. So 4x, if I subtract the 6 from both sides, 4x is going to equal 12. And then divide both sides by 4, x is going to equal 3. So I know that the price of soda is $3 and the price of chips was $2. So I can say that the soda cost is $3 and the chips cost is $2. So that's that. Awesome. We created two equations and solved for them. Moving on to number 4. Rashid works as a driver for both Lyft and Uber. After expenses such as insurance, taxes, and gas are taken out of his pay, he makes about $20 every hour for Lyft and about $18 for every hour for Uber. Let L equal the number of hours worked for Lyft and U equal the number of hours worked for Uber. So now they're defining our variables for us. The following equations are true. 3L equals U and 20L plus 18U equals 370. So first we need to explain what 3L equals W tells us about the problem context. Well, what this is saying that the times worked here are equal. So he worked at Uber 3 times as much as he worked at Lyft. So how would you want to explain this? We can say something like Rashid worked 3 times longer for Uber than he did Lyft. And then part B, explain what 20L represents in the problem context. So 20L, let's see. Well, L represents for the number of hours he worked for Lyft, and he makes $20 every hour. So what 20L represents is the total money earned from working at Lyft. Total amount earned from Lyft. Likewise, what 18U represents is the total amount earned from Uber, because the U represents the total hours worked times how much he makes per hour. That's the total amount. So this would be the total amount earned from Uber. Now part D says to explain what 20L and plus 18U equals 370 tells you about the problem context. Well, this would be the total amount earned from Lyft. This would be the total amount earned from Uber. So this tells me that he made $370 total. So Rashid made $370 total. And then he used the given equations to determine the number of hours Rashid worked for Uber and the number of hours he worked for Lyft. So now we're going to be solving this system of equation. So let me just rewrite it so we have it here. We have 20L plus 18U equals 370. And we have 3L equals U. Well, what's nice about this is that the second equation is already solved for U, so I'm just going to use the substitution method. I'm going to take the first equation and plug in 3L for U. So that will give me 20L plus 18 times 3L equals 370. And now just solve for L. So 18 times 3, what's that going to be? 54. So 70L plus 54L equals 370. Total of 74L equals 370. And let's see, I believe that's 5. Yes, so L equals 5. So he worked for a total of 5 hours for Lyft. Now to find Uber, I'm just going to plug in 5 for L. I'm going to use the second equation. It's already solved for U. So 3 times 5 is equal to U. So 15 equals U. So this is telling me that he worked for 5 hours for Lyft, and he worked 15 hours at Uber. So Rashid worked at Lyft for 5 hours and Uber for 15 hours. Awesome. All right, let's move on to number 5 here. James participated in the P.F. Chang's marathon in Arizona. He decided to do the full marathon, which is 26.2 miles, even though he had not trained enough to run the entire race. James jogged twice as many miles as he walked in the marathon. Let J represent the number of miles James jogged, and W represent the number of miles he walked. So part A, we need to write the two equations to represent the situation, and then to define our variables clearly, which is already done for us, but we'll just restate it. And then part B, use the equations written to determine the number of miles that James jogged and the number of miles that he walked. So, let's see, J was the number of miles jogged. I should say jogged, sorry. And then W represents the number of miles walked. So let's create these two equations here. Let's see, what can we gather from the text? So James jogged twice as many miles as he walked. So can I say that that the jogging, if he jogged twice as long, that jogging is equal to 2 of the times that he walked? Yes, that's a true statement. Can I also say that his number of miles jogging plus his number of miles walking is equal to the total number of miles in the marathon, which is 26.2? Yes, that is also a true statement. So now that I have my two equations, I'm going to solve for them. And this problem just screams substitution because I already have one already solved for J. So I'm going to plug in 2W in for J in the other equation, which will give me 2W plus W equals 26.2. Oh, that's, my penmanship's not the best. Okay, so let's see. So that would be 3W is equal to 26.2. So dividing both sides by 3, W will be, let me make sure I get my math right. And I'm going to round this to 8.73. now that I have the number of miles walked, I can just plug it into one of the equations and solve for the number of miles he jogged. And I'm just going to use the first equation again. It's a really friendly equation. So J is equal to 2 times 8.73. Let's see, times 2. That's going to be J is equal to 17.46. So he walked for 8.73 miles and jogged for 17.46 miles. So I guess we could just write that. James walked 8.73 miles and jogged 17.46 miles. All right, let's take a look at this last one now. Planter's Honey Nut Medley Trail Mix contains 4 grams of protein per 1 ounce serving. Planter's Dry Roasted Peanuts contain 8 grams of protein per 1 ounce serving. Let's see, suppose you want to create an 8 ounce mixture of the mixes that has a combined total of 42 grams of protein. So we need to write our 2 equations that model the situation, and then we need to solve that system and explain what our solution means. So let's first define our variables. This time our variables aren't defined for us. So my go-to is always x and y. So x, let's see, I can say x is the ounces of the trail mix. And y is the ounces of the dry roasted. So let's create our 2 statements here. Let's see. I know that, well, the mixture that we want is going to have a total of 8 ounces. We want an 8 ounce mixture. So I know that the number of ounces of the trail mix plus the number of ounces of the dry roast is going to equal 8 ounces. So that's a statement that I can use. Another statement, we can say something about the grams of protein. So let's see here. I know that for the trail mix contains 4 grams of protein for every ounce, and the dry roasted contains 8 grams of protein for every ounce, and the total number of grams of protein would be 42. Is what we want in our mixture. So again, here we want to solve for this, and I'm just going to use substitution. In this case, like I said, it's my go-to. So I have x plus y equals 8. I'm going to solve for, I guess we can solve for y. So if we have x plus y equals 8, solve for y, we subtract x from both sides. Y is equal to 8 minus x. And I'm going to plug that into the other equation. So we're going to have 4x plus 8y, but I know y to be 8 minus x equals 42. And again, just solve. So let's see, 4x plus 8 times 8 is 64. 8 times negative x is minus 8x equals 42. Combine like terms here for the x's, so 4x and negative 8x gives me negative 4x. And 64, well, I'll just do that in the next step. We're going to subtract 64 here from both sides. Negative 4x is equal to, let's see, 22. Wait. Yeah, 22. And then divide both sides by, negative 22. And divide both sides by negative 4. So x is going to be equal to 5.5. So the x, so we know in our mixture that we need 5.5 ounces of trail mix. Now I can plug it into, again, the first equation and solve for the number of ounces of dry roasted. So I can say 5.5 plus y equals 8. Subtract 5.5. So y is equal to 2.5. So explain what the solution means. Well, in our mixture, we will need 5.5 ounces of, see, X was the trail mix, and 2.5 ounces of the dry roasted. I guess we could say in order to have an 8-ounce mixture of, what was it, 42 grams of protein. And that's that. So that is Module 5 homework. I hope this video helped, and I will do this again for Module 6, so have a good day.